the second part of using PyLucene for retrieval. Now, earlier we have used PyLucene for performing the retrieval in a given collection, right? Now, in this part, what we'll be doing is we'll be using the PyLucene for searching. So, in order to search, what we will be given is basically we'll be given a query, which will be basically a string, along with the language in which it is written and stop word list. They are basically, implicitly can be approximated from the string itself, from the string or the query itself by some form of, say, generally the type of query that we'll be handling will be from the basically English query. So otherwise we need to detect the language and we need to provide, or we need to use the corresponding analyzer to analyze the query, and the same analyzer should be used which was used while indexing as well, so that a word to be mapped to a word, say x, to be mapped to x prime if it is during indexing, as well as if the word is given as a query while retrieval. So while searching, it should also be basically mapped into or transformed into the same term. So we need to apply the same analyzer. So together with the query, what we need to do is, so from the query, we can understand this language and stop word list based on which we'll be setting the analyzer. Together with that, we need to be providing the search system with the index path where the index is stored, the search field, the field on which, based on which the searching will be performed. As we have seen in the Lucene index earlier, the PyLucene index earlier, there were two fields. One is the plot and another was the title. So if we want to search on the basis of the term occurrence in the plot, we need to provide that. If we want to search on the basis of the term occurrence on the title, we need to provide that. That is in general is indicated by the search field. And the top list, that is how many top documents we want to retrieve. That is how many top ranked documents we want to retrieve. The output will be a list of documents, of course, you can understand. And of course, as we have said, based on the language, we need to set the analyzer which is used while indexing as well. Otherwise, we will not be getting a good match. Now, graphically, the Lucene, the searching component of Lucene works based on this. So this is basically the query. So using the query parser, which is basically using an analyzer, basically converts the query into a query object. So object of the query. And that object of the query is passed on to the index searcher. The index searcher uses an index reader, which actually reads the index. So this is basically the index, which is stored in the directory, in the physical directory that we have seen. So index reader is actually read the index from the secondary memory, that is our hard disk, and it returns a set of top documents based on their score. So again, note that this analyzer should be the same, what we have done, what we have applied while indexing as well. So the first thing that we need to do is, while creating this or while performing this search, is to set the analyzer. So the analyzer can be set following the same mechanism, like so basically setting, what we have done using while doing the indexing. So here I am defining a search module or a search function where I am providing two parameters as basically the index path where the index is stored and the query. And inside that I am setting the analyzer to English analyzer. I am assuming that I have used the English analyzer while indexing as well. The next thing is, as we have shown here, we need to use this analyzer to define a query parser. And the query parser, together with the query, we also need another thing. It is basically the field to search. That thing is also to be provided to the query parser. And the analyzer will be, as we have already said here. So together with the query, we need to also pass the field to be searched. So this search field is basically, I'm considering it as a plot, hard coding it here. Of course, you can consider it as a parameter. Say, if I write say, SF here as a parameter, we can also consider passing the parameter as a parameter or an argument here in the function body, in the function signature. So here the query parser is set. The query parser is taking two parameters. It is a function which is defined in this package which I am importing. Now it is taking two parameters: the field to be searched and the analyzer to be analyzing the query. Okay. Now the next thing from the diagram is using. So far what we have done is basically we have set this query object. Now using that query object, what we need to do is we need to open the index searcher for the retrieval. So in order to open the retrieval, open the index for retrieval, we'll be using, as the index is stored in the file system or in the secondary space, we are using this fs directory, the same fs directory that we have used for while performing the index. There we are passing on the index path. This is exactly the same command or same statement that I am writing, which I have written while performing the indexing. And then based on this directory, I am basically initializing this index searcher. So this index searcher is being initialized with this. Now, in the diagram, what we have seen is together with using the query object, we'll be performing the searcher. So until now, what we have done is we have set this index searcher, which is basically reading the index from the directory, and it is ready to be searched. Okay, it is now ready to be searched using this search or using this searcher object. Now, so far we have discussed many searching algorithms. For example, we have discussed BM25, we have used LMJM, or we have defined language model with Jelinek-Mercer smoothing. We have defined language model with Dirichlet smoothing. We have defined TF-IDF smoothing. So far, these are the retrieval models that we have discussed. Now, the next thing is, here we need to actually set the similarity function as well. So based on which similarity function we'll be performing the search. So to do that, there is a function called set similarity. And the set similarity function takes a single argument, which is the name of the retrieval model. Here, BM25 similarity, LM Jelinek-Mercer similarity, or LM Dirichlet similarity, all of them are again implemented inside Lucene or PyLucene here. So I'm importing them. So of course, in a search, we will not be importing all of them. We will be importing either this or this or this. Now, BM25, as we have seen, it has two parameters, K1 and B, having their individual need for controlling the document smoothing, basically the document length smoothing, or basically considering whenever the document, whether we'll be considering the raw document length or the smooth document length, and so on. So K1 and B are basically associated with the individual smoothing parameters of BM25. For Jelinek-Mercer, what we have seen is basically the lambda and 1 minus lambda is basically the linear smooth language, the linear smoothing parameter. We need to pass it as a parameter here. And for LN Dirichlet similarity, we need this mu parameter, which is basically can be set to somewhere. So lambda is set between 0 to 1. mu is set somewhere between 100 to sometimes 3000. Again, these are based on the data set that we are using to perform the search. Then finally, so until now, what we have done is we are set with the searcher module or the searcher object to search the this directory or search this index path. Now we will be performing the exact search. So searcher.search is a function. Here I am passing, so query is the query object that we have defined here. This is the query object returned by the query parser. Or you can say this is the parsed query, what I am passing here. And this is basically the top doc. The top number of documents, top highly ranked documents that we want to be retrieved. Okay. Now, after doing that, it will be basically returning a list of documents, basically a list of documents. In order to access them, we can actually perform a for, we can use the for loop statement to access the individual document and their corresponding fields. So again, searcher.doc. So earlier we have used searcher.search to get a list of documents, and then searcher.doc will be basically returning the content of the document as a Lucene doc type. So note that the same Lucene doc type we have used while creating the index. So that thing will be returned by this doc function. Now here, scoredoc.doc is basically the internal Lucene doc ID, which is specified while performing the indexing, which is basically set for all the documents while performing the indexing. And there basically, if there are say 1000 documents in the collection, then the internal document ID, Lucene document ID will be from 0 to 999. So they are basically linear in nature. So this is basically the internal Lucene doc ID, based on which Lucene distinguish the documents from each other. Okay, and based on that, using this get function, we can actually get the information stored in an individual component or individual field. Individual field. So here we have used we have stored the title and title and the plot. So using this get function, we can actually access the title of the document, the retrieved document, or the plot of the retrieved document. Now putting everything together, the function would look like this, the retrieval function. So let's write this function. Let's try to implement the same thing. I'm just I'll be copying the code so that we can save some time. Sorry. Here, and also we need to import some important modules as well. So those will be importing later on. Let's see. So this is basically the function that I have shown here. So we are calling the function with this index path where the path is stored. Then we are we're basically passing the query itself, and we are setting the analyzer, then setting the directory, then setting the searcher, setting the similarity function with similarity BM25 similarity say K1 and B. Let's say set to 1.2 and 0.75, which is the default. And then we are performing this search. Sorry, first we are defining this query parser and basically defining this query object. Here search field, as I have said, will be basically the say plot, and the analyzer is set earlier here. And here what we are doing is basically performing the search with top size, let's say 50 or say 10 for the time being. Let's set it to 10, and that's it. Now, before doing that, we need to import. We need to import some important modules as well, like org dot search import searcher. We need to import some more from index as directory reader. Sorry, mistake here. Okay. And then we need to call this query. So I have all this thing written in the slide, and I'll also be sharing this Jupyter notebook as well. And another import that I need to do is searcher.similarities. Import say PM25 similarity. Now, first of all, of course, we need to initialize this, initialize the virtual machine. This thing I also need to do. So index path, where we are storing the index. So here the index is basically this, because here I hope you remember that I have stored the index here in this notebook path here. So this path is set here. And now what we need to do is we need to, so let's, for the time being, let's keep it in a separate cell, which will be, no, not this one, sorry, this one. Oops, a mistake, PM25, yes, this is executed. Now if I execute this, you can see it has executed so far flawlessly. Now we'll be calling the search function with say index path, which we have set earlier. Index path is, let's check it. What is the value of in index path? Oops, no, it's basically index underscore path. What is the index path? Extremely sorry. Index path is how I'm defining the index path. Oh, it's basically converted into two paths. Okay, so don't need to do that. So index path I'm setting here, I'm passing here. So we actually don't need to, no need to actually set. So just for the time being, we can just simply pass on the path of this directory inside the code. And the second parameter of the search function is the query itself. Let's say I want to search for the query, say murder. Oops, there is an error. Search field is not set. So let's set the search field. So you can see the line number is 16. So here in this function, the line number 16 is search field. Let's say plot. And the field to retrieve is also, so let's say, let's make it say title. Now, if I execute this, you can see total 10 documents as I was setting, 10 documents are retrieved with the title this, and this is the plot. Now, let's just for the time being print only the title. So, searching with murder, we are getting these 10 documents as the highest scored ones. So just to show you that we are actually doing everything in the correct way, let's make it murder with capital M. So murder and murder are different, but after performing the analyzer, it should be providing the same rank list. You can see they are actually providing the same rank list. Rank position 1, 2, 3, and all are same. Also, let's check with say murderer. See that for murderer there is no hit. So murderer is not actually being transformed into or stemmed into the term murder. So that's why we are not getting any match for this term murder. If I search with another term, say crime, you can see crime is present in all these documents. Now let's again, for the time being, if I print the plot as well, let's just for the time being, let's execute it. So crime was the searching term, and this is the document in which, so this is the document in which crime has been found for the highest number of time, or for the query crime, this is the top ranked document. Now you can see crime is present here, crimes. So the movie name of the movie is Military Raj. So Mithun played the lead role. I'm sorry for that. When there are crime situations, so here is this is crime, crimes, and so on. So based on the query crime, we are getting this document. Let's make it a crime and murder. So for the query crime and murder, the top rank document is Wings of Courage. So this is the document. This is basically the plot of the movie. In 1920s, South America, a small group of French pilots led by aviation pioneer Antonio de Saint blah blah blah, which was played by Tom Hulce, struggled to prove they can offer a reliable airmail service over the Andes. When one of the young airmail pilots, Henry blah blah blah, crashes on the blah 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 blah. I'm sorry, where is the term crime here? Let's see. Can you find the term crime or murder here? I think murder is here. Whether there is crime. I don't know how this document is being scored the top rank. This is really funny or weird. Really, there must be something that I'm doing wrong. Search, no. Top rank document. So 10 documents are being retrieved. So for the time being, if I just print the query, we'll be able to understand why this is actually happening. Also, not queue, but query. We'll be able to understand why this is happening. Yeah, the and is not actually not being removed for some reason. I don't know why. So you can see the query crime and murder has been transformed into searching into plot for crime, searching into plot for and searching into plot for murder. This should not be the case, but yeah, I'm sure it's something that I'm doing wrong. Okay, then let's discuss this next week. Oh, next week is a basically off week. So I don't know why this is happening. I mean, if I search with crime, it is actually providing me with the correct output. If I search with murder, it is being, so this is the list that I am being returned. And here there are multiple murders, but for multi-term query, there must be something that I'm doing wrong. But I'm not sure what I'm doing wrong here. Plot, note that I have written in standard analyzer here. Instead, what I need to do is I need to write English analyzer. Thank God that we actually encountered this. This is something that will be easier for, yeah, now you can see the and is removed. And the top rank document for the query crime and murder is this. This is the movie title, and this is the movie plot. The plot is saying the court system, burdened by the massive number of crimes being committed, introduces a new trial system, the bench trial system, blah, 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 blah. But note that there is only one query term occurring, which is crime, no murder. For the second, oh, okay, no, not actually. This is the entire. So the entire, wow, this is a huge plot. So in the plot, you will be finding crime and murder. I am sure multiple times, crime here, murder here, and so on and so forth, many times. Thank God the problem is fixed. I mean, problem is detected. So the problem was earlier we were using standard analyzer. As I was saying, we should be using the same analyzer that we have used while performing the indexing.